Thanks for coming. Let me just run through briefly what this meeting is about and what it's not about, so we don't
So we stay on track.
don't spend too much time spinning off in any direction. This is Little Pond Lower Watershed Sewer Collection System Options. It's a long way of saying what we're here today to talk about. First question everyone's going to ask is, why are we talking about Little Pond and the watershed there instead of any of the 14 other estuaries the town has? There's several reasons for that. Reason number one, back 30 years ago when the town put in the sewer system we have now, the plan was always to continue on and add the lower part of the heights on the east and Mara Vista. The system was actually designed for that area to be included. Now, for 30 years, the town has not done it, but that's one reason. Second reason is the selectmen several years ago decided out of all the 14 estuaries the town has, they were going to concentrate first on the ones in T-Ticket and East Falmouth because those were the most impacted. As you well know, if you ever look at Little Pond or Great Pond, they're in rough shape because of septic, because of road runoff, because of fertilizer. But the biggest piece is the septic. Third reason we're here and talking about this particular part of the town is that the town meeting unanimously voted $500,000, and the selectmen unanimously approved a comprehensive wastewater management plan, which says you will do this area. Fourth reason, as I mentioned earlier, Little Pond is the worst impacted of all the estuaries in town. Fifth reason, the committee thought this was a good one to start with, it's the smallest watershed and the most densely developed. It's the closest to build out of any part of town. Sixth reason is it's the easiest one to hook up to the existing system because 30 years ago, the existing system was designed to take that volume from that area when it was built. And the seventh reason is kind of ties into all these other reasons, which is it is going to be the least cost per household of any of the areas we could possibly sewer, and the greatest nitrogen removal of any part of town that we would consider. So that's why we're talking about here. What this meeting is not about, it's not about alternatives. We're not going to talk about eco toilets. We're not going to talk about any of these other permeable erected barriers, any of these other things that town meeting asked us to look at. We are looking at them, and we spend a lot of time on them. They're not the topic today. Okay? It's not about the exact boundaries of an area to be sewered. The consultant's going to show you maps. The maps are a work in progress. Where the exact boundaries are is not a finished thing. So you can't look at this map and say, my house is in, my house is out. We don't know yet. Third piece, it's not about effluent disposal sites. Where the septic goes, it's going to go to the plant in West Falmouth. That's a given. Where it goes after that is not a given. It's still a discussion matter. It's not a discussion matter for today. Fourth, which I know is going to be in everybody's mind, who's paying for this and how much are they going to pay? That's not on the table today because we don't know. We don't have an idea. You're talking about a system that hasn't been designed. There's a whole bunch of pieces here that have to be settled before you can answer any of those questions. If there's going to be betterments, how much they'd be, nobody can know until you know how much it costs and until the town makes decisions about where it's going to get the money, whether it's going to get a 0 interest loan or a 2% loan. These make huge differences to the cost of this thing. Nobody knows, so we can't talk about it at this point. What this meeting is about is this. The sewer world is a lot different than it was 30 years ago. Back then, the big pipes, 12 feet down on the ground, was the only option that really anybody considered. That's not the case anymore. There's other options, which we're going to talk about today, which are cheaper in many cases, less intrusive. I mean, they all have pluses and minuses. We're going to talk about them today, but it is not all about big pipes anymore. We're here to explore all those options, and particularly how they would affect people who live in these neighborhoods. So we've invited people from the T-Ticket Association, from the Heights Mara Vista Association, Finance Committee. Judy's lived in the Heights all her life, and she's been on the Finance Committee or or the staff of the finance committee almost all of our life. You know, we got this guy spent the last 3 years immersed in sewage, and he's back for more. These folks lived in the Heights all their lives. You've lived there. We wanted to make sure you were here to get the picture and to think about it and to give us your input. Because, you know, you're going to have to know about it. You're going to have to live with whatever the town ends up doing. So the purpose is to explore these options today. No decisions are being made today. The consultant is here to tell you where their thinking has gone, to tell you what the options are, and to get your input. That's what it's all about.
And you should introduce the consultant.
Jeff, from
GHD.
They changed their name, I can't use it.
Good morning, everyone. My name is Jeff Gregg. I'm from GHD Inc., formerly Stearns & Miller, for those that know both. And what I'm going to do today is just talk to you a little bit about the different technologies that we've been asked to look at for collection systems. So I've got a handout I'll hand out, and I'll just kind of walk through the basics of the different types of collection systems, and then talk about what our task is for these various areas and some of our progress that we've made to date. As Eric indicated, we aren't finished. There's no decisions that have been made yet. We haven't done any of the costing or any of those things. But it's really to use this forum to help educate the group and answer questions and receive feedback on the various different technologies and get those questions. And if there are questions that I can't answer today, I'll certainly will have them documented, and we can work on at least trying to you know, get back on what some of those questions are to see if we can address those. So what I wanted to do is I wanted to start off.
Make sure we have enough for the audience. We can share.
Pass out a few of these. It's just what I find. My wife always tells me that it's easier for her to see things than to actually hold something. And I apologize if you can't always. It's tough to take pictures of things that are going to be in the ground, and certainly what they look like afterwards, because usually all you see is the street and some manhole covers. But what I wanted to do is I basically put together some information on the various different technologies, and so what I wanted to do is start on the gravity sewer side and just kind of walk you through what we're looking at here. I presume most people are familiar with what a gravity sewer would entail. Basically, you have a pipe that's set at a constant slope, so it's angled downward so that flow will flow from manhole structure to manhole structure, and then ultimately it'll end up either at a collection pumping station or it'll end up directly at your treatment plant. In the case of Falmouth, your treatment plant is way over there, so it's got to be pumped there. So you'll see with all these technologies, anything that flows by gravity, and pressurized, is going to end up at a pumping station that will then eventually end up at the treatment plant up in West Falmouth watershed. So on the picture on the upper left is basically just an example of a small pumping station, pumps inside the building. It looks like basically a Cape Cod home. The dynamic would be, you know, for a house next to that, on the right-hand side, you can see wastewater will come out of your house. You may or may not have a clean out at your property line. It will tie into a gravity sewer. There may or may not be a manhole in front of your home. Manholes in the street, typically about every 300 feet, or a change in direction of the pipe. It's typically done with what they call open cut, so that's the picture in the lower left-hand corner. So they'll cut through the pavement, they'll excavate down, they'll lay the stone, they'll put the pipe in there, and then they'll backfill, and then you'll end up with something that looks like the picture on the lower right. Basically, you'll see a manhole cover and usually a paved road. Depending on how, every town is different. They may have, towns will have paving plans, and this would be applied to most of the technologies, but If a town has a paving plan, they may just do a trench repair and then come back and resurface the road afterwards. It all comes down to how they want to do it, what other projects they're doing. Some towns elect to do water work at the same time, or there's underground utility work that happens, like the gas company, in case you're going to drive anywhere on the Cape. This past year, the gas company was everywhere doing their gas improvements. So a lot of times, towns will try to piggyback that. It is very disruptive. All construction can be disruptive, but there are ways to work around it: communication, traffic management, informing the public so that people know what to expect, and so on.
Could I just say one more thing about, these pictures are very useful. To look at the scale of how deep this pipe is, the pipe is blue down at the bottom, and you see a man, and he's well below ground level, and this large metal object that's around him is called a box. And so to do all of the excavating, it has to be done within a box. And so you dig, and then you have to move the box, and then you dig, and so on. So it's slow and it's deep if the system is entirely by gravity. And the system that we have installed presently in the town was all gravity sewers, and I remember in the 80s seeing the machinery inching down the street.
And you can have gravity sewer that's 4 feet deep, and
That's
you can
right.
have gravity sewer that's 20 feet deep or more. I mean, in major cities still, you know, 'cause they gotta get below everything else, and they gotta put in a big pipe. We're not talking, you know, this typically is, you know, between, gravity is typically between 8 inches, and I think in Falmouth, I think your largest is probably in the order of 20, the existing is probably in the order of 22 or something like that.
22 inches pipe
Yeah, diameter.
diameter.
Yeah, so just under 2 feet.
And how deep?
I think it ranges, and I'll be honest, I haven't looked at the profiles recently.
At least 6 to 8 feet probably
Yeah.
is the minimum. I don't think, you might have a few, a little bit
Right.
high of it.
But most of it is gonna be, you know, it's typically gravity sewers, you'd like to get them between, you know, 8 and 12 to 15 feet, because you wanna make sure you're trying to pick up the properties by gravity. The advantage of a gravity sewer system is that the connection from your house to that gravity pipe is just a pipe. So it just flows by gravity, you don't need to pump it. You know, again, the trade-off is that you have to get water to flow downhill, so you have to get it deep enough to deal with topography and things like that. And that's some of what we're working on when we're talking about the various different collection systems. And I'll go through the posters later. I just wanted to talk about the technologies first.
Could you talk a little bit about risk?
Risk?
Yeah.
With
About
regards
risk,
to-
with regard to each of the systems you're discussing, like some of them are risk, less risk, financial or environmental, or whatever those may be.
Why don't I introduce all the technologies, because there's a lot of similarities between them, and,
Okay.
and one of the things I'd like to point out is that if you talk later, when I talk a little bit about the septic tank effluent gravity type systems, it's still a gravity system, so you still may, although the pipe diameter is smaller, you still may have the same issues of getting deep enough to get it to be able to connect properties by gravity and things like that. So I'll walk through these, and then I can talk about some of the, you know, the risks associated with those. I won't cover them all. We are developing a technical memorandum that will talk about the pros and cons and advantages and disadvantages of the various different technologies that we're considering.
And every time I look at you, I think of energy. Relative energy costs will be discussed. And, you know, just put out there how energy may or may.
Yes. I mean, as part of the essentially the technical memorandums that we're going to be developing as part of this, there'll be one that's essentially focused on the technologies in general, the pros and cons of the different technologies, and then we take that and then we'll have a more detailed one that's going to be specific to the area we're talking about, which is essentially the Little Pond lower watershed for, you know, plus or minus. And then that's when we can start talking about the costs associated with those, the capital costs, the operation and maintenance costs associated with those, and that gets into energy, energy use. But some of those things are also, there's some decisions that the town is going to have to make with regards to those technologies. Ownership is the biggest issue. And what happens, and if you lived in an area where you could do everything by gravity, you might have a main that would run down the street, and then you'd have lateral services, but the town would basically stop this, they would stop their lateral service at your property line, and then you'd be responsible for making the connection, and they'd leave that to you, and they'd provide that service. When you start getting into grinder pumps, vacuum sewer systems, step and stag systems, which are septic tank effluent pumping and septic tank effluent gravity type systems, then there's the question of ownership, installation, because now you're talking about facilities that could be located on private property. And so that's another thing to consider. And that's not to say that the town couldn't also take ownership and get an easement for a gravity lateral service, but they just typically don't do that if they don't need to. So moving on to the sort of the next picture, it's grinder pumps. Now, are people in the audience familiar with grinder pump type systems? Have they ever heard of them? Basically, a grinder pump system is, you may even have something very similar to that in a septic system. If you had a septic system where you actually had to pump to your leaching field, you would have a small pumping system in your backyard that would pump from your septic tank and it would pump to your leaching field. But it typically wouldn't be a grinder pump. What a grinder pump would allow you to do is it's usually a standalone tank. The wastewater from your house will come in, as you can see in this figure, and come into a structure. The structures are typically, I don't know, a couple feet in diameter, to up to 3.5, 4 feet in diameter. There's a structure, and there's a pump in the bottom of it, or 2 pumps in the bottom of it, and then it would pump by a small diameter, which would typically be 1.25 inch diameter, so fairly small pipe that would go out, and it would tie into the sewer main. And it's kind of like a water system backwards, because you'd have a curb stop at the property line, you have a small service coming from your house, and then you have a larger pipe that's conveying the wastewater, in this case, under pressure, to either an intermediate pumping station or directly up to a treatment plant if need be. To give you an idea, the picture below that gives you a typical view of a trench. In this case, it's high-density polyethylene pipe, so it's kind of flexible pipe, which you can also put in PVC, which just looks like a miniature version of gravity sewer pipe. It's just got thicker walls, so it can handle pressures. In this case, it's fused together, so they have a tool that heats up the pipes and they basically butt weld it together. And then in this case, this trench is about 4 feet deep, so they have about 4 feet of cover. Now, some towns may require that you have it deeper. If you're in colder climates, there's a concern about freezing. You typically want to get it below frost depth. And as Virginia pointed out, in the gravity example, you had a trench box. Well, if your excavation exceeds 4.5 feet, then you're going to have a trench box regardless of the size of the pipe. So whether the pipe is this big or this big, if you're past that OSHA threshold, then they're going to have to put a box in, which makes your trench wider. Now, it doesn't have to be as big a box because it's not as big a pipe, but it's still going to have a structure. So there's safety considerations for that as well. And then ultimately what would happen, and there's some other pictures I'll show you, but in New Silver Beach, they have a grinder pump system that basically, they have some flow that comes by gravity from a couple homes and actually goes to a grinder pump, and then they pump it up into their gravity system, I believe. And they actually have this structure, which you can't see, is inside of this, what looks like a manhole above, is the grinder pump. So it's basically protected, and then they have a control panel because it's serving more than one home. Typically, on an individual home, you'd have something that would look like the picture in the lower left. You'd have a little cover that you'd see that's about 2 feet in diameter. It only sticks up about this much, and then it has a panel that's probably 18 inches by a foot, and then maybe 8 inches deep or so, a little red light on it, and that usually gets mounted to the side of your house or to a fence rail or,
Is that what this is?
yeah, it's very hard to see, but there's a little box that's kind of on the right-hand side of the building, and
Jeff, you may want to point out that most of the ugliness in that picture has nothing to do with the sewer system.
yes, no, I know. What's unfortunate is that the example that I had was from a rural area in New York, and this was one of the nicer pictures that I had, so.
Nothing in Falmouth Heights looks like
I
this.
know, so,
Well, we have a number of these in Little Harbor, in Woods Hole, where they pump with a grinder pump into the force main, so it's not like New Silver Beach where it's into a bed.
That's right.
and then on the, and unfortunately, I didn't have a picture of those, so, or I would have had a nice picture of the granite pump. But what I've shown here is, and I apologize, it is even a little hard to read, but there are two different technologies that the committee went to visit. Went to visit on the vineyard. One is the E1 type grinder pump system, which is what you saw on that picture with the little disc cover. The other one is a Myers. There are others. The Myers is more like it's a slightly larger structure, so the cover is slightly larger, so it's probably closer to 2.5, 3 feet in diameter. But basically, a pump sits on the bottom of that structure. Your flow flows by gravity from your house, as if it would to your septic system, but it would go to this structure, and then it would be pumped out to a small diameter. And to give you an example, the diagram in the lower right-hand corner kind of shows you as flow comes from your house into, this is the E1 example, and then it's basically a high-density polyethylene structure, and then it pumps it out, and then you have a curb stop at the property line, and then it ties into the small diameter main. And the small diameter main in the road is typically between 1.5 to 4 inches is typical. And if you had to pump further, then you have to get a larger main because you have to deal with head losses and velocities. And these types of systems can either pump into their own system and then eventually end up dumping into a gravity collection system. They can go directly to a pumping station, and they can go directly to the treatment plant. In this case, again, because the treatment plant is so far away, it's very unlikely that we'll look at that alternative. It will likely end up going to some of the existing collection system or other pumping stations proposed or existing to ultimately end up at the treatment plant.
The ones that we've had in Woods Hole have probably been there for 10 years, and as far as I know, they've been fairly trouble-free.
So now this grinder pump system eliminates the need for the traditional septic. It doesn't work with it, it replaces it, correct?
You can do two things. It typically replaces it. So in the case of most people's septic systems, they've been in the ground for over 20 years. The integrity of the tank is, there's a question about, how good the tank is, and so depending on the age of the system, it's easier to go in and install this. I mean, the E1s, they literally come in with a little, looks like a little bobcat with it, basically like a big auger on the back of it, and they just auger it down, and they plop it in. If it needs some kind of balance because you're in groundwater, or you think that you have the potential for groundwater coming up, they'll put a concrete footing around it to hold it in place, and then that would place your septic tank, and then it would go out. They do make these types of systems that can either go in your house, and they also make them that can go into your septic system. Like if you had a brand new septic tank and it was easy to kind of go in for that piping, you could have that unit installed. They typically don't like to do that as much because and it may be more expensive because it's more of a specialty setup for them, because then you have to deal with making sure that you have it set up so that you can get the rails in, and you actually have to go into the structure to make sure that your pipe's coming out through that septic tank, through your effluent discharge location. And I'll talk a little bit about that with the step systems, but it is possible, you can do that. But these are typically what I would call a canned unit that would come in, they plop it in, it's what they call plug and play. And you plug it in from your house and plug it to go out, and then you wire up the electrical and go from there. There is an electrical service that's required because it's a pump, you need power, so there's alarming and things like that that all come into play. And again, then it starts getting into that ownership line that needs to be discussed with the towns, really where that'll be.
What's their typical holding capacity?
It depends on the system. Now, the E1 is like 50 to 70 gallons, and the Myers, I think, was upwards of 150 plus. And I apologize, I don't know the number right off the top of my head.
Which means one of the considerations that we should be thinking about is when we lose power for 2 days for hurricanes, we better have the capacity to hold it in that tank.
Right. You either need to have the capacity to do that, or you need to make sure that the provisions are made for, you can do pump outs. So what you would do is you would have basically they put a pigtail, or they have a plug-in point for emergency generator, and the town, if the town were to go down this road, would likely buy another, basically a portable genset that they could then have their crews go around and do they could do the pump out, plug it in. It doesn't take long to eject that system. There are those abilities as well.
We talked about this in the menu, and one thing they pointed out is if your electricity stops, a lot of what you put into the system stops. You're not washing your dishes with your dishwasher, you're not doing your laundry. All the kind of things that put a lot of water in aren't happening when your electricity stops.
Just another thing is the capacity is one thing, but the good thing too is that when they do fail, there is this whole alarm network. It's got lights, flash buzzers go off, and so people know pretty quickly, and it's usually, like on the vineyard, they have like 24/7 people who would be able to get there and deal with it. But they do have problems occasionally, and the rate is not that great, but it does happen. And different systems wear out sooner than others from what we heard. I'm not sure, I can't remember which is which, but one of these two it seems to be longer lasting or something. The other thing too to factor in is that because it's electrical, and depending on your service at your house, there could be an electrical upgrade, which would mean a new panel. It's kind of a big deal. It may have to be done if it exceeds what your limit is, because your box is rated at a certain level, and I think most are probably okay, but it's just something else that people should know.
Yeah, one of the things that came up in the vineyard in certain areas is that if a street only had a certain, phase of power or a certain voltage, that if it was a specialty voltage or a less common voltage, you just, as part of the design, need to make sure that you're picking that up so that when the town, depending on whether the town's buying them or the homeowner's buying them, that the information's out there so that if the town, some towns buy them in bulk and then make them available, some towns buy them and install them, some towns say, no, the homeowner's going to deal with it, but depending on whatever the situation is, you would then just need to be aware of your power requirements so that you have the right pump installed.
Jeff?
Yeah.
Does anyone ever run a power line parallel to the street line? And then in the emergency case, and coupled with the town owning the pumps, so then the town would also power them. You wouldn't have to worry about upgrades, and in the case of a power outage, you'd only have to connect your generator for each block, say, at a time.
I suppose anything's possible. I have not seen that, because when most utilities don't want to get into another utility, so they don't want to be a power utility, and I think that there are certain things that if you start laying lines and, I can speak from experience. I was working in a town, and it was the power lines were owned by NSTAR, but the poles were owned by Verizon. And so if you had to have something done, Verizon had to go in and set the pole, and then NSTAR had to come in afterwards and set the wires. And so then if you introduce the town, then you could have potentially three owners. And then if you had a problem, you have to literally go through 3 steps to get that resolved. So,
I think both of these systems, and there might be a third system out there, just because we mention any of these systems, it's not like, just, you probably got your hands on quick, easy.
yeah, these are just examples. I picked these 2 because these were the 2 that the committee had gone out and actually seen installed. There are others. The state of Massachusetts does require 3 or equal, which is very hard to do because there aren't always 3 equal manufacturers of something. You may find that the town will elect to standardize around one technology, and then they'll go through the process of making a proprietary selection, and they'll get it approved so that they can document the fact that, hey, you know what? We don't really want to have 7 different, pump fails, and we own all the grinder pumps. We don't want to be, oh, geez, this neighborhood's E1, and that one's Myers, and that one's another company, and which pump do I have to, or it's a smattering in, in the neighborhood. There will be a point at which the town will want to standardize around certain things so that it makes it easier for maintenance.
Seems like you could easily hook up one solar panel to run something like this and then be self-sufficient.
No, because it's a high peak power.
Is it?
You'd have to have a lot of storage.
Oh, really?
What you could possibly do is that you may not be able to run the pumps, but you may be able to deal with the panel, the alarm panel, meaning so that you know that you have, granted, if you're in a hurricane, you don't have any power, but at least you'll get an idea, better stop flushing the toilet right now, and call the, DPW to see if they can come and hook up the gen set and pump us out.
So I'm not sure if the Vineyard did it, but I think I know these 2 manufacturers, at least one of them, probably both of them. You can get slightly larger tanks. I mean, there's a point where you might say the bigger the better, but it's not always the best. So that might be a decision later on what size we standardize.
Yep.
We asked both of these towns in the Vineyard, which have had them in place for, one has had them for 10 years, one's had them for maybe 7 or so. We asked them about frequency of repair. How many times did the town get called out to fix something in one of these? And in both cases, it was like once a month. And it was usually because some kid had put a G.I. Joe down the toilet, or something major had gotten into the works that had made it need repair. But the number of repair calls were very, very low, considering they had hundreds of these installations that had been in place for quite a few years. So that was
Reassuring.
comforting, yeah.
There are, as technology is advancing and you can access pretty much anything on your smartphone, they have instrumentation programs relatively inexpensive that would allow, them to set up a network too, that the town could see pump failure. Even in non-storm events, they could see pump failures and things like that and kind of deal with preventative maintenance before it becomes an issue. There are those things. Again, it all comes down to cost. And what the town is going to want and what their goals are to achieve for putting in a different type of collection system. I'd like to flip to the step page. And now I apologize that I don't have a whole lot of information on these. These are not as common in New England. There are systems. I mean, pretty positive that my parents had one up in Winnipesaukee. I remember my dad putting a cup on his toilet and saying, "Please leave a quarter here every time you flush." So a step system works in a couple different ways. You can do it, but essentially what it's doing is the STE part of it, the septic tank effluent part. Now, the P stands for pumping, so in this case, you would have flow, and the diagram that I have here, flow coming into a septic tank. And then they actually have it flowing out of your septic tank, and then going into another pump chamber. So it's kind of like you're intercepting the flow before it gets to your leach field, and then instead of going to your leach field, this would go to the main in the street.
So it'd be both liquids and solids flow out of the tank, and we're getting everything out of the tank.
No.
Just liquid.
No, and so the idea is septic tank effluent. So the idea in a septic tank is that the solids are being collected at the bottom of your septic tank for the same reason you don't want them going to your leaching field to clog that or your D-box. You want all that there, and then you have to have a septic hauler come in, and they would periodically pump down that tank. And so you would get most of the clear liquid. Now, depending on how the system is and the type of step system, you still have to be concerned about some solids carry over. You do have to be concerned about, grease, oil and grease. It's a problem with all technologies. And so some of these systems will actually get retrofitted into your existing septic tank. They have basically a chamber that would slide down. Again, it's a function of if your septic tank is older, it may have a smaller opening at the top. Do they have to make a modification to get it in? But they can do that, and basically it creates a barrier, a baffle, so that the solids again stay at the bottom of the tank, and then that what you consider the effluent, the clear effluent would be the liquid coming into your pumping chamber. And then the idea is that these systems are removing some of the solids, so you just have to be able to make sure that your treatment facility that's receiving it, that you've taken into consideration what the design impacts are of that, because in the solids there's nutrients and food that your biological system that the treatment plant may need, but it also avoids having solids settle out. You can go with slightly smaller pipes because of the fact that you're basically pumping what will be considered a more clear liquid in the world of wastewater. It's just a clearer liquid. And so they do have one of these systems in Gloucester, I believe.
Yep.
And
Basically, the Seacrest is set up this way. So the Seacrest does that. They have big septic tanks in each one of their units. They then pump over to their treatment plant the liquids, and then regularly, at least annually, they have to pump out each of those the solids out of each of those septic tanks. And those go by septic hauler to the treatment plant, to a treatment plant.
it's very common in those types of systems. Schools, a lot of schools will have them too, that have a flow that came to a septic tank, and then they had to build a treatment plant, and then it'll be picked up, pumped out of there, and then go to the treatment.
So you'd have a huge reserve for power outages.
You have
The
it.
size of your septic tank, it's like 1,500 gallons.
Yes,
instead of
presuming
50
that your system was pumped down, but yes, you would have a reserve in that structure. So if it had been pumped out or pumped down, presuming you weren't at high
Well,
level.
the solids are a small fraction.
No, but I guess my point,
Depends on when the cycle is of the pump going on.
yeah, my point is that yes, if the power went out before the pump had pumped the tank down, then you could have less volume than you would if the pump had just gone and drained your tank, because there is a working volume that you have to pump.
But you could
there
easily
is
make
more
the set point be considerably below the maximum.
Oh, yes.
septic.
Yeah.
We usually do.
Yeah, and you want to keep it high enough so that it's, so that you're getting clear liquid, you're allowing the solids to settle out. But yes, you would have certainly more storage volume, or the potential for more storage volume in these types of systems.
Another advantage to these too is that the solids and things are in the tank for a long time, which means that they will basically break down on their own at the site, okay, at your home, basically. It's just like your septic tank. So the load going to for treatment, in terms of the nutrients, and nitrogen to remove, is much less.
No, I think that's questionable.
But,
That's questionable. It's highly ammonia. It's a lot of ammonia in it.
No, I don't-
Why don't you answer? I mean, yeah.
Yeah.
It'll all depend on the types, how many of these systems you have, what the wastewater flow is going to your treatment plant. I mean, this could be a small percentage of your total process, but the concern with, as you remove the solids here, you they do need to be treated at some point somewhere, and septage is harder to treat at a treatment plant than wastewater, because you've now separated out the two things. And wastewater that doesn't have all that solids, you may find that you're adding more carbon up at your treatment plant to do the biological process to remove the nitrogen, because you have a very, high nitrogen waste. That's not to say that's, again, it depends on how your overall system is and how it's combined with other things, but those are impacts with those things. So there are pros and cons to both.
And that problem is still true even if the septic haulers who pump the tanks take what they get out to the same plant.
Because what happens is when you take it to the plant, you're putting it in a different part of the process, and septage is harder to manage. When they pump in septage, they typically get it in, they'll store it, and then they bleed it into your system.
Right.
As opposed to just dumping it right in the headworks. Because it's like a shock load, because it's almost.
Well, they can put it in wherever it's best.
Yeah, well,
They choose where they put it in.
Well,
They're not gonna put it in the worst place.
No, but it depends, again, your system, your treatment plant would.
Our treatment plant has limited option for equalization. This is not necessarily a huge problem, but there's no doubt if this option was chosen, we'd have additional tankage design or equalization design at the treatment plant. I think we'd have to get with the designers to make sure this gets blended in better so we don't violate the permit. It's not as easy. This is, let's say the whole peninsula, and this is where we get. Let's say it's 200,000 gallons. Current flow is 400 to 500,000. That's half or more of the current flow. There will be process changes that have to be significantly looked at to take this much septic tank effluent flow. The septic is no different than what we have now.
Yeah, I mean, I think what it comes down to is what you may experience with a septic tank. If you have a septic tank effluent type system, it's very likely that the town is going to then, if they take on the management of the pumps, they're going to take on the management of pumping that system. And so therefore, that septage, which could normally go to wherever that septic hauler would take it, may be mandated that it go to your treatment plant so that you're dealing with it, so you know how it's being dealt with. You may elect to say, no, septic haulers are just can take it wherever they feel it needs to be processed. But septage is more difficult to manage than at a treatment plant than just raw wastewater.
I'm just looking at the fine print.
Yep.
It's hard to read here, where it says, it's left in there for passive natural treatment. So basically, it's passive natural treatment, so it means that it has time to break down. It doesn't mean you eliminate all the issues with it, but this is saying that there is some treatment that happens on site without the need for the plant to do all the.
But what you pay for, Ron, is that the plant, you then have to add the carbon that's breaking down in the septic tank.
Whatever.
To get it to
Just saying what it
denaturify.
says here.
Yeah, but it's what it says.
And I guess on the flip side of the breakdown of that material, which isn't bad,
Yeah.
is then you're left with a lot of inert material that you have to manage as basically a sludge. So there's a trade-off there as well. And again, I'm not saying it's any of these things. Again, I don't want to present this as anything more than I'm just trying to talk about all the different technologies today.
I think, well, one question is that we now truck a lot of sludge off-take from the plant. So then, I guess it'd be a trade-off you'd have to look at in terms of how much less more sludge that would be done through the passive process. These are all just questions and not.
There's one basic assumption that is being made here, and that is that the septic tank will serve this system, that the septic tank is tight and new enough, and we are dealing with an area that has been developed for a very long time. And so one of the things that the committee is doing is looking at the Board of Health records to get a sense of how many of these systems are really old, how many of them are actually Title V and would fit into this category. And until that research is being done now, and until we get a handle on the relative percentage of old systems and new systems, That's just another variable that needs to be looked at as we narrow down to what we think is the best system that would work for Mar Vista and Falmouth Heights.
Right. A lot of these places may still have cesspools, as you well know. And if that's the case, of course, it would
This
be
is out the
completely
window.
irrelevant.
Well, to clarify, it wouldn't be out of the window, it just means that you'd be
Install a new
installing
system.
a new tank.
Yeah.
You'd be putting in a tank, but it'd be a tank that we manufactured with the pump unit already in it. I mean, it wouldn't, they're designed for that, and they come in and they, similar to the canned unit for a grinder pump, it'd just be a bigger canned unit, and they'd install that.
And they wouldn't have to put a leach field in it.
No, none of the, all of this is
Leach
collection
field.
system, so I just used the leach field as an example to give you an idea of like what you have now, or what you may have. You know, most systems, you know, if it's a Title V system, it's gonna flow from your house to a septic tank, and then it's gonna go from your septic tank to a leaching facility. Now, there are a lot of cesspools, so you may have it flow from your house into a cesspool that goes into an overflow cesspool. And that's basically just a big round concrete tank, or maybe made out of block. I mean, and it's basically just a way to try to get that into the ground. So,
You know, I always read what vendors say with skepticism. There's generally, and we've got two people probably due to time with it, the septic tank in this picture is the same as the septic tank in your home. So you get the same passive removal as you would with the septic tank. So there's no difference. There is a difference then because of solids carry over where you could clog your soil absorption system, okay? This says 10 to 12 years. I think they're pushing the envelope. You don't want solids flowing over into your leach field, and we don't want solids flowing over into the pump system. Whether it's 10 years or 5 years, I don't know. But so there are some similarities, but there are some things where every vendor, and I don't care what the vendor is, they put it in the best light possible.
What I don't, variation on the step system is the steg system, which is septic tank effluent gravity. Now, the septic tank effluent gravity system would basically be if your house was located in such an area that you could have flow through into your septic tank and then into a gravity system in the street. They do talk about the ability to, and this is where I'd be very cautious, but they talk about the ability to flow a septic tank effluent gravity system into a septic tank effluent pressure system. But you're asking for an awful lot of design considerations to make sure that that house is high enough that when those other pumps kick on, they're not pumping the other way. So,
Coming back to you. Oh, good.
So, when we'll be talking about septic tank effluent gravity systems, we'll be talking about them basically as an alternative to a gravity system. So you'd have potentially a smaller main in the street, but you have to be able to get from your septic tank to the street. The disadvantage of a septic tank effluent gravity system is the idea that if your septic tank's in the back and the sewer's in the front, then you've now got to get it around your house by gravity out to the street. And then you still have the same issue if you had a cesspool now and you need to have a tank, you'd have to put in a septic tank to do that. Again, it's, you know, they're all possibilities. It's very similar to the septic tank pumping system. The advantages aren't as great because even if it's a small diameter pipe, a 2 or 4 inch pipe located 12 feet in the ground isn't that much cheaper than an 8 inch pipe in the ground at that same depth because you got to get down there. So it's really, the step system is the one that gives you more advantages because you are pumping, but you're adding an electrical system to the process, yes.
Is there a need for uniformity? If we had some houses that had Title V, could use a step, and then another, if it was more feasible to use a grinder pump?
It's very possible. And again, that comes into the design considerations. Now, what it comes down to is the pumps. Some pumps are, the E1, the biggest difference between like an E1 system and a Meyer system with the grinder pumps is one's a positive displacement pump and one is a centrifugal pump. And so, I know
Everybody
that,
understands.
well, that's why I'm going to explain. So the difference is, in very general terms, is a positive displacement pump will pump at a fairly constant rate, and it doesn't care what the head pressure is, which is being the friction and head loss that you have to pump against. Where a Myers pump is a centrifugal pump, so it can pump at a variable range of flows, but all of those are impacted by head losses in your system. So when you design your system, all those things come into consideration. Your pipes will get larger as you're trying to deal with pumping it further away or higher flows to make sure you're maintaining velocities in your system. And they're all design considerations. So for a lot of these systems, though, you could be, if you had a gravity main in certain locations, and then you had people that are going to have to pump, they could be pumping in, and you're talking very short runs. So the impact is probably not going to be noticeable, so that you could have that person that's got, I mean, even if someone had a septic system now that had a pump in it, and they pump to their leach field, they basically have the potential for a step system. So in the future, the town could make provisions to say, we'd allow that person to, if the pumping system would work and they can document that they can pump into the system, they could then pump up either into a gravity or pump up into a low pressure system using some of the facilities they have. They may not be able to, but it's certainly things that you can consider and take in, keep in mind. In this area, the lots are so small that I seriously doubt that there's anybody that pumps, but maybe there is. Maybe there's
No.
somebody that has to pump around their house, but in most cases, I don't think so. I think most of these are so small that you're not gonna find that advantage.
I know we're not talking about financing today, but if we got into this kind of patchwork approach to sewers, then would the betterments be the same or different and tag, how would that all, that sounds like.
I know, and
Yeah.
really, the question.
Quick answer is we're not talking about betterment.
Yeah.
But it makes it
Oh, the
complicated.
chim.
To be fair, I think I've heard from you before that we don't want a patchwork, because just in terms of maintenance and keeping parts and things like that. The town wants to have some simplicity if they're going to be in charge of fixing things.
Oh, yeah, that side of the town would want consistency.
The question was, can you do that? Yes, you can. And then you bring up the bigger question, which is what I talked about at the beginning. It all comes down to the ownership and ultimate operation and maintenance of the system that you select. And then that's where those decisions will be made. No, you know what, we're gonna mandate that whether they have a pump or not, we're gonna mandate that this is the type of system that they have. This is the type of technology that they're going to put in so that it's consistent, because the town is elected to, and I'm not saying they're going to, I'm just saying, in this example, the town is elected to take that direction and take on the responsibility of maintaining those systems, if they did that. So they would want to set those things. They may say, no, we'll set some regulations on what we're going to require, but we're going to leave the operation and maintenance to the homeowner itself. Again, these are decisions that haven't been made. They will need to be made, and they're important, and they all come into play with how you will ultimately deal with financing these types of systems. Any other questions on step before I move on to vacuum? Vacuum, and I apologize, my figure's a little off here. On the upper right-hand corner, you have your house, and similar to your septic tank effluent or your grinder pump system, flow would come into what they call here is a valve pit. It's basically a fiberglass structure that receives flow, and then it would then have a valve in it that allows flow to get pulled from that structure into the main. Now, a vacuum sewer system is what I like to refer to as a gravity system on steroids. It's basically, it has to be designed like a gravity system, but it has some advantages because it allows you to do a sawtooth configuration.
You don't have the first page.
On the first page to show you from a lateral, but the ones in the main are the same idea. Flow will come down at an angle to a bend, and then it can get pulled up horizontally, I mean vertically, and then it flows down to the next bend, and then it can get pulled up in the system. But there are limits. You can't just put like 8 gazillion bends in there and just think that you're gonna pull it all the way up, because you're limited by friction losses in the system and the amount of vacuum that you're pulling in the system. And then once it gets in the main, it will essentially, it's a gravity pipe, and then what the idea is that you don't have to necessarily go as deep, because you can put in lifts, which are these bends, and you can get yourself to get back up closer to the ground surface. The disadvantage, as I said, is, you know, all that comes at a cost. Some of the advantages are, if you know where utilities are, you can use these to get below utility and then come up and gain some grade. One of the things that nobody ever talks about with the collection systems is there are other utilities in the ground. And everyone kind of likes to, you know, oh, we can put this in and we'll go up 4 feet and we just sail along and we'll be done in no time. But you've got all your water mains, all your water services, you've got a mishmash of electrical and gas and telephone and cable, and depending on where you are and what the neighborhood is, there are all these other utilities. And so it's usually first come, first served, and sewer is usually the last guy on the street. So that's why sewer ends up going deeper. So even on some of these smaller, what are called smaller pipe diameter type systems, you still have to get below water. And you have to get deep enough so you're avoiding freezing and things like that. So there are considerations to that. The gravity system the vacuum system has the advantage, like a gravity system, that there's no power required.
At the site.
At the site. There is a pumping, all of these, because of where we are, all of these technologies will require some sort of pumping station somewhere to pick up flow to get it into the system, because not everything will be able to connect directly into the existing collection system for various number of reasons. The valve pit does not have to be located on private property. The town of Barnstable, and I know because I designed the system, the town of Barnstable elected to put all their valve pits in the road right-of-way, which meant that they had the valve pit in the road right-of-way, and then they had a vent pipe, which used to be back then a candy cane kind of looking thing. You might see them on septic systems. Now they have a little prettier looking box. Basically, there's a way that they need to introduce air into the system prior to the valve so that you don't collapse your valve pit. But you have all those along the street line, or you can have the valve pit closer to the house and have that vent even closer to your house, or, you know, depending on where it's going to be in your property. But you are required to have a vent, and you would have this. And the structure, again, looks like a manhole cover. So you'd have a manhole cover that'd be in your yard. It could be flush with grade, so you can mow over it and all that kind of stuff, and things like that. The disadvantage of a vacuum type system is you're building a pumping station that's going to be slightly larger than most conventional pumping stations, because you've got to have a receiving tank, which I think I have pictures on that. And later on, I'll show you the station. So there's a receiving tank and some other appurtenances, but you need more pumps because you have vacuums, and then you have to have a discharge pump that's pumping it somewhere.
I think there was just one more point, and that is that, as you said, this is the advantage of the electrical of things at the house, but what we understand is that if you're in a community like ours, and there happens to be a bunch of houses at the end of the line that are on the sewer, and none in between because it's seasonal, then it doesn't work very well. You need a consistent thing, you need people all the way along to make it operate. So that's another factor that particularly related to our situation.
Yeah, what the system will do is it relies on all the other valves to pull in air into the system, because that little slug of air is basically acting as a plunger that's helping push your flow, and you're pulling it with your vacuum. And so if what happens is we've seen this in a number of different communities, if you have a flow at the end or a larger flow at the end of the system, you can overwhelm the system if you don't have enough little guys here to kind of help shuttle it along. And so every time, what it does is every time the valve opens, it takes and it sucks out the wastewater, you know, instantly, and it pulls in a puff of air right behind it, and then it closes. And it's open very short time. It has no issue with sucking up pretty much anything. I mean, you know, it's pretty impressive. It's, but they do. It's a fast, quick action. The sumps aren't very big, so these only have they're doing an action on essentially 10 gallons. So they have it set typically that you get 10 gallons of flow in, and the valve says, okay, I see 10 gallons of flow. It's got a pressure differential that it senses, sucks it up, puts it into your main, and then it waits for the next 10 gallons to come down. Which means that you don't have a whole lot of storage. I think they say that the unit itself, as it starts backing up, would have, I think like on the order of, I want to say like 30 plus gallons, maybe more, and I apologize, I don't have the number off the top of my head. But you can get deeper sumps, like we talked about with the grinder pumps. You can get extended sumps. Some of those is just so you can reach your system by gravity. You know, get from your house to that valve head.
Since it relies on electricity, open the valve and pull it through, wouldn't the fact that there's not much storage be a problem
It doesn't rely on electricity at the property.
at the property?
It relies it at the station, but stations are all gonna
Stations have the
stations gonna
backup generator.
And this one, you know, you'd
Yeah.
have a,
Yeah,
an
you'd
emergency
have to have it.
generator, you'd have to have that,
Yeah,
and that would kick on, and that would allow your system. These systems also don't fail typically in the close. So if barring, not talking about storm events or anything like that, but if your system had a problem, what will actually happen is the valve will actually stay open, so it'll just continue to suck. And what happens is then, at the station, wherever the station is, they would see a loss in vacuum pressure. And then they would go, okay, now we gotta go find which valve is open. And then they have a process to go through to find that open valve.
The committee actually went to Barnstable and looked at this installation that they put in. I think it's fair to say they weren't recommending it. And we didn't go to Provincetown, but we know they're not recommending it. Because they actually had a failure there during the 4th of July weekend a couple of years ago, when they couldn't get a repair person in a timely way, and everything backed up into everybody's house and business on the 4th of July weekend. So it has some real deficiencies. And in Barnstable, at the end of the day, it didn't save them much money, according to the operators. So they weren't recommending it.
The bigger difference too with Barnstable, and I'd like to clarify, is that, you know, they elected to put it into a very commercial area. So they had some very large flows at the very extremities of the system. And so that added to some of the issues that they had. And they had a very steep learning curve. So it's like 10 years later, and now they kind of deal with it like they deal with all their other stations. But in the first couple of years, they were spending more time just because they had to learn the system. And your installers have to learn how to install the system because it's particular. You can't have any leaks or the system will not work.
Jeff?
I'm sorry.
Eric is right, of course, and we got these anecdotal reports on the 3 different kinds of systems from the places we visited.
Yep.
You were with us.
Yep.
But you presumably have access to sort of, is there some industry-wide collection of average maintenance data and so on, analogous to the building cost books? Or, so you don't rely on anecdotal information? How do you know more reliably? I mean, yes, we heard really negatively about vacuum systems, and it makes sense, and that people on Martha's Vineyard each swore by the particular pump system that they purchased. But does somebody collect this nationwide to get it?
I don't know if anyone collects that nationwide. There is a lot of data out there from installations in place that talk about electricity use and things like that. The difficulty is that you can get broad perspective, but every system truly is unique, because this person may have this fancy SCADA system that allows them to respond in a certain way, and this one may be a small community that has to deal with it a different way, and their costs are different. And these guys may be contract operators, these are town employees. So there are other things that get into how that operation and maintenance cost is developed. So when we talk about costs, we'll be talking, you know, we're going to try to build off of the information that we have available to us on these different types of systems, and you know, a local experience with regards to what the cost is, what they charge, what their responses are. Some of the things we have to rely on the manufacturer as well, because they maintain some of these systems. You know, there are towns that'll have service contracts with the pump system manufacturers or their suppliers, and they come out and maintain that equipment as well. So you could have an arrangement with a company that deals with technology A, and they come out and you say, okay, you know, we have a service contract, and we have failures, we need you to come out, come and service that piece of equipment, and then it's however you negotiate with that contract with them too. So that's why I think that there isn't one nationwide version of, you know, how they maintain that cost. Some places you're going to be dealing with groundwater, and some places you're, you know, not. So that's, you know, I apologize, I don't have a.
Thank you.
I'm going to jump in if I can.
Yeah.
I think if you think about a vacuum system and if something goes wrong with the vacuum system, what you basically get is a fault that ripples over almost all the people that are connected to the vacuum system. Each person that's dependent upon that to clear out is going to sense that fault. If you have a sewer going to a pump station and there's a fault at the pump station, usually the lowest connected homes will see the problem first. Not everybody, but one or two homes. No, this is just how it goes.
Yeah.
If you wind up with individual grinders or whatever at individual homes, you wind up with very individualized problems to go address. So I think the knock on the vacuum systems is that while they're pretty reliable all in all, when they have a problem, it's a problem that everybody sees. So you don't have the case of 5 or 6 people who are like, every time there's a problem 2 years ago during a lightning storm, and I had, you know, a problem at my house because the sewer pump station went down and the town didn't get there fast enough. You get everybody in the neighborhood going, what the hell happened? Okay, so it's a little more systemic failure that
Yeah.
goes through everybody's home.
Right, it's a good way of phrasing it.
And it also gets into, again, the level of pertinences and features that you put into your system to help you maintain that system. You know, Barnstable knew that the vacuum sewer system is right next to their treatment plant. I mean, it's literally the main drag right in front, and then down 28 towards the rotary. So it's really close, so their response time could be, during normal hours, could be much shorter on that kind of thing. So they made some decisions as part of their process on how they were going to maintain their system. So those are all things that come into play with that as well. Just to finish up on the vacuum, so if you have a larger flow, then you typically go to what's called a buffer tank, and that would be for commercial or a larger user. And this just gives you kind of an example of what that might look like when the flow comes into basically a manhole that's got these 10-gallon sumps at the bottom, and then it flows up. And you know, this layout looks very similar to the New Silver Beach kind of on the surface. They've got a concrete structure with a hatch and a panel.
Would we expect this for like motels and inns?
Yes.
Right,
Yeah.
not for individual homes.
No, you know, the mall, for example, would have that. And that'd be a large enough user that you wouldn't typically, you could build it with a bunch of little vacuum pits, you know, to deal with it, or you could have it all flow by gravity to a point, and then basically a buffer tank acts like it's sort of a vacuum pumping station kind of thing. It's just a larger area to receive flow. And then you can see an example of a candy cane. They now don't, this little,
They now have a box.
They now have they have a little box that comes up, basically to provide it there, or to make it look a little less hygienish. So what I'd like to do now is just kind of walk through some examples of the various different types of stations that are associated with some of these technologies. So on the next page, I have, it says Falmouth station types. This is to give you an example of what you already have in town. So, New Silver Beach by the ocean, it's actually a submersible station, which you can't see. It's where the two guys are leaning over looking in the tank. And then the building itself is just really for the controls and the generator. And it's elevated and built so that it can deal with flooding issues and things like that because of its proximity to the ocean. On the flip side, Falmouth High School has actually 2 submersible stations. And you can see everything's flush at grade, and there's a panel there. You really can't see much of anything. Inner Harbor, Falmouth Beach, and I didn't show it also, it's Gardner Road. They have what are called Boyd Code type stations, which typically have this structure that sticks up, and you basically go inside of a can unit. And so you have a wet well, which is where the wastewater comes into, that's separate from basically where the pumps and the operators would go in the controls and backup power is. And then the Jones Palmer, and also I didn't show the Shiverts Palmer because it looks almost just like Jones Palmer, and Shiverts Palmer pump station is actually right over there. You know, it's a more industrial building. It's a more traditional, what they call a wet pit, dry pit, which means it has a wet well, wastewater comes in into that area. It's got certain hazards and classifications associated with it because that's where the wastewater comes in, and then you have the main building, the dry well, which is where the pumps are, your generator controls, and all that kind of stuff, and it looks more like a structure. One of the technologies that I don't believe Falmouth has, but may,
Right here, sure, for a second. Sorry to interrupt you.
no, sorry. Suction lift type stations. Now, a suction lift type station, a submersible station is going to work a lot like your grinder pumps or your septic tank effluent type systems. You've got a tank, your pumps are sitting down at the bottom of that tank, there's a rail system that pulls it up. Operators don't go in there, they have to pull the pumps out to maintain them. In a suction lift type system, you have pipes that go down into a wet well, and then you have a set of pumps that's actually sitting on the ground, or in some cases like a Boyko setup into a unit. And so you can have them set up in little fiberglass enclosures, like the pictures on the upper left and in the middle. You can have them in a little Cape Cod house, like you see on the lower left-hand side, or in the far right-hand side. You put fences in front of them, you can do all kinds of different things, but that's a suction lift type station.
And that's for the vacuum system?
No, this is actually, we've actually now jumped back to, this would be for any type of system besides the vacuum. So if you had any kind of system that has to pump to a pumping station to get it up to your treatment plant or into your collection system somewhere else, you could have one of these types of systems.
I see some push, some pull.
Correct.
Okay.
But the vacuum station is its own beast. So what it has, and if we jump to vacuum stations.
I just want to jump in here.
Oh, yeah, sorry.
That's all right. Just to try to clarify this, the earlier pictures I showed you from the town, though, on a number of those, they're what's called submersible pumps. The pump is down in the liquid, and when the float signal tells it to come on, it comes on, okay? The suction lift says the pump actually sits up out of the liquid, and there's a little way to sort of prime the pump. So if you've ever had to take a pump where you've got to prime the pump to get it going, basically the suction lift pumps have to be primed to get going. They've got a little vacuum pump there that will make sure to pull it up to the pump before it starts. So oftentimes it becomes a decision at the, what I would call the operation or maintenance level. Do you want to have to pull the pump out when it messes up, out of the thing, clean it off and fix it? Or do you want to have to make sure to maintain this vacuum pump along with the pump, where it's up above But on a suction lift type station, you do have a limit to how high you can go. You can
Correct.
only pick up what the atmospheric pressure above you is. So if you've got to pick up more than 25 or 23 or 25 feet,
You're pushing it.
you can't use a suction lift station.
Or-
But it's basically an operator's type decision, I think, about what do you want to own and maintain. We're back to try not to mix and match.
Well, the other thing
Try not
that
to
may
mix
be
and match. And
confusing.
already the town's got a couple of submersible pump stations, so we may already have started down a path there. I don't know, Jerry. You'll
I don't
have to
know
jump
either.
into
I
something.
mean, it's-
Okay.
Just one little thing in case some people are confused by it. We've made the transition now from talking about hardware at individual houses to the main system, the neighborhood or the town law.
Correct.
Main-
Sorry, I didn't,
Yeah,
I should have been clear.
and I think the main point is that obviously there will be these pump stations in some locations. So what might they look like? Would they be completely underground? Would they look like this little shed here? And that's what we saw in Vineyard Haven when we went. It was right outside the parking lot from where the steamship authority was, and you would never know that it had anything to do with sewers.
Are there typically, in stations like these, are there typically odor problems that arise sometimes?
Again, you can design and put in odor control systems. And again, it depends on how big the system is and how long you think the wastewater is going to be sitting in that type of system and what kind of neighborhoods it's serving. And odor can be subjective, you know, and I say that meaning that some people may be a lot more sensitive than other people. And I'm not saying that that's a good or bad thing. It all takes is one person to complain about odors and you have an odor problem. So, but you can make provisions to deal with that.
I think it's safe to say we will make provisions. I don't know if any new pump stations made without some type of provision for putting it in
I always
at
point out,
time.
that- I always
I'll
point out,
put
it says
in.
odor control, not odor elimination.
Yes.
Yeah. The other thing is,
You control your odors and hopefully then nothing ever goes wrong.
Yeah, that's true. The other thing is, all these may look ugly, and depending if they're in my neighborhood, your neighborhood, or your neighborhood, the neighbors may want certain architectural things differently. Some people may want a fence, other people may want arborvitae's. You know, there'll be plenty of opportunity for discussion on how this blends into a particular neighborhood.
Wasn't there some money appropriated recently to fix the odor problem that everybody smelled at the Shiver's Pond station?
And Palmer, both.
No, this one will be starting next week or next couple
Yeah.
of weeks. There's some delay in fabrication of certain tanks.
Are the submersible ones less likely to have odor?
No, it's not a function of the pumping technology type.
Okay.
It's a function of the wet well. Flow coming into the wet well, how long it sits in the wet well, you know, where it's coming from, how long it's been in the system before it's gotten to the wet well, that kind of. Those are the issues.
Okay, thanks.
Yeah. So those are some examples of suction lift types. Now, the vacuum sewer system, if you look at the bottom two pictures, actually the bottom three pictures,
This is Barnstable.
Barnstable and Provincetown. So the far left is Provincetown. You can see all these guys jammed into this room that basically is not much bigger than that on the other side. So there's a tank in this basically, you know, bunker below ground, and all their pumps, both vacuum and their wastewater pumps, are upstairs to pump it up to their treatment plant, to suck it in from their collection system and pump it up to their treatment plant. The disadvantage of this kind of configuration is, God forbid you ever had to do anything with the tank, you're basically taking the whole building down. And the building itself is the one that you're seeing, it's their public restroom. So they built it in and they did a nice job, and it's right downtown, and if you didn't know, you wouldn't know.
You do expect some odor.
Yeah, exactly. It's a nice way to camouflage it. Then you can see in the middle picture, you can see that's where all the pumps are set up, and that's basically the first floor. So you're walking in, and then below that is where this pump room, basically this tank room is. In the Barnstable facility, theirs is on their treatment plant site. It's certainly a more industrial looking building, and it's got odor control. Vacuum systems have to have odor control because you're pulling air from your collection systems. You're pulling all that stuff all that air from the whole system, and you're pumping it through the building, so you've got to run it through some kind of odor control. And in that case, we made provisions to, they wanted to be able to expand the system, so they didn't put in, there's another tank that they wanted to be able to put in, so that's why they have large doors, which you can't really see here, they're on the face, that's a separate picture. But you can open up, you can actually monorail in another tank, and then they can pipe that all in and set that up. And so, again, it's set it's just sort of like a big industrial building. I'm not really sure how to else explain it, but, so that's like a vacuum sewer. And then on the back, are some examples of submersible and wet pit dry pit stations. So we talked about submersibles before, and on the far right-hand side, you can see a shot looking down. You can see the pumps are at the bottom. There's a rail system to allow the operators to pull the pumps out. The biggest complaint we get from operators is, man, it's a pain to pull those suckers out sometimes if you're not set up properly, because sometimes they torque, or they don't get it lined up quite right. And,
How heavy are they?
well, the pumps themselves are, it depends on the size of, it depends on the size of the pump and the size of the motor. So you can have everything from like a 50-pound pump to, probably close to 1,000 pounds.
Yeah, we're probably looking at something in the 800 to 1,000 pound unit submersible, depending on how big a station it was.
Jeff, it's fair to say that the collection radius for all these systems is big enough that you would not have anything like this in the middle of a residential area? Or is that not fair to say? Or does it depend
You mean in terms of the size of the facility? Oh, like the station? Is that what
Well,
you're asking?
is there a possibility that there's a big brick house
Oh, no.
is going to be plunked down in the middle of one of the,
I don't know.
I don't think so.
What I'm trying to do is give people an example of what these things look like, and just because, that's serving something like Jones Palmer, so it's
That's a big station.
a big station, so it's receiving a lot of flow, and it's kind of like a hub.
We're not talking about that.
And then you're going, Falmouth High School is a picture below, which is the submersible station. And then, so for the wet pit, dry pit, to give you an example, in the picture in the middle, the black are the channels of the flow coming in, and then they go into two wet wells, and they have grinders, inline grinders there. And then on the other side, you can see the tall pumps in the green, and that's where they're pulling it out of the dry well side. So,
Jeff, you can drop it. Just first passage, there was a pump station. How many homes would it be serving, do you think, roughly? 200, 400?
for a pumping station,
Yeah. What I'm doing here is that there's a picture here that you've given of New Silver Beach.
Yep.
And the New Silver Beach pump station is currently serving about 200 homes, just to give a benchmark of what a pump station that serves 200 homes looks like. Steve, you're asking something looks like.
Yeah, well, I figured the
This,
neighborhood,
if
that's
you go to New Silver Beach, this is sitting right in the middle between a couple of homes. Okay? And you drive down the street and you say that's a little bit of an odd looking building because the other homes aren't raised up against the B zone yet. So there's a building that's raised up a little higher than everything else because it's built to the current flood zone. The velocity zone way one of the issues. And you kind of go, oh, that's a kind of a small building compared to some of the other cottages.
Other cottages wouldn't survive the pump
No, and
station.
it's a new building, but it doesn't look entirely out of place.
Right.
And that gives you a sense of the size of the building for 200 homes. So I was asking roughly, we're in the same general category, maybe a little bit bigger. Yeah, we're not gonna call 1,700 on a pump station.
what you would have is you're gonna have, I'll sort of jump ahead. We've looked at a couple different examples, and these
Maybe
are,
not to jump ahead there yet, just to let people know that when you get into the 200, 300 home pump station size, New Silver Beach is a good one to be looking at for what it looks like
Would you agree?
as a structure.
yeah, and you can, even with the suction lift type stations as well, you can build a structure that looks like,
Yeah.
a small house. It doesn't look like this big thing that looks like a library or whatever, brick, municipal building. And then that's where you get into the advantages and disadvantages of, how you're dealing with your above grade and below grade structures. How many things, submersible, the advantage of a submersible system is, it only has to be as big as the electrical system to house your electrical system. Everything else is below grade, and you never see how big that tank is and how big those pumps are. You could have, 500, 600 gallon a minute pumps in a submersible station. Maybe, you gotta make provisions to be able to get them out of there, but you could do that, and you're not gonna see them.
The only reason the new Silver Beach one is as tall as it is because it's in a 100-year floodplain. And so it's up on stilts, which if you're above 14 feet here, you wouldn't have to have that first story there.
But I'll stand at that picture, you look at the Falmouth Beach one that you're looking at, that is also in the 100-year floodplain. It's all below grade, with a generator in it, with the cap that seals off, and the vent pipes that run up a telephone pole above the elevation, but it's more money to build that type of station. Okay, so you can do it either
Make
way.
sure they don't have any questions.
Yes, I was gonna say, thank you for coming.
Oh, you're welcome.
Any questions or anything that we could help you
I
with?
found out what I wanted to know. No, I did,
Did you?
Yeah, I hate to rush, but we got 11 o'clock appointment.
No,
It
fair
was very
enough.
nice that you came.
Yeah,
Thank you very
thank
much
you.
for coming.
I'm glad
Very
you're part of it.
informative.
Yeah,
Good.
yeah.
Nice people. Thank you all very much.
We
You're
appreciate it.
welcome. Take care.
Thanks.
Let's get into the business of the area and how you came up with what has to be done there.
Move this one there first, just to, everyone see that? So just in general, the area that we're tasked with is essentially this area in beige. And we just broke it out into pieces because we needed to.
Okay, well, they can't all see the writing. You have to tell them what they're looking at.
Just orient.
Oh.
Where's Falmouth Heights, where's Mayor Vista?
This is T-Ticket, this is the mall, Spring Bars Road, this is Mira Vista Avenue. This is Worcester Court, kind of some of the general.
Now, the reason this area is the area, because it's the lower watershed of Little Pond, and immediately, the mall area immediately above it, which has problems. So that's why this area. Little Pond is the rebel spot, and this is addressing that rebel spot.
So, just for the purposes of what we at GHD have been doing, we wanted to break some pieces out just so we could, made it easier for us as we're starting to look at layouts. So we kind of look at basically the Mira Vista Peninsula is one item, the area up by the elementary school in the northern part of T-Ticket is another area, and then this area down here, it's Falmouth Heights and the Worcester Court area as a separate area. We've also identified the fact that although it wasn't in the original layout that we were talking about as part of facilities planning and things like that, in all reality, anything that happens here with regards to a collection system needs to make provisions for what might happen down here. So in terms of sizing, it doesn't mean as part of what our task is to do a 30% preliminary design and do identify these evaluations of the various different technologies and outline that work, but we need to be cognizant of this. We also need to be cognizant of the fact that in reality, Falmouth Heights sits out there, and just in terms of provisions, we just need to make sure that we know that if anything ever had to happen here, how that might fit into the bigger picture. But that is not our task. We're not doing any layouts in this area. We just need to be cognizant of the fact that it exists. And that's the reality of all of this work is especially when you have areas that are isolated from the rest of parts of town, that you wouldn't want to make considerations for that. So this is the general area we're looking at, and then what we're doing is we're going through the process of doing some layouts of different types of collection systems to see how we might address these various different areas. And right now, we've only gotten as far as dealing with the gravity and low pressure, and then the all low pressure type system. Now, the gravity and low pressure can be either the step and stay type system, the gravity and grinder pumps, gravity and step pumps, or all low pressure is just, you know, anything that's everyone's on a pump system. So what we started to do is look at, well, we had to identify, well, where were we going to try to put a pumping station? And so that's the biggest question. So when we started the project, as part of the facilities plan, I believe, there were some areas that were identified as potential locations. And we were looking to try to site a pumping station somewhere down in the southern part of Mira Vista, somewhere either north of the mall or along in the mall area or adjacent properties, and then somewhere down in the Worcester Court area. What we determined at this point is buying property, and there is no real vacant lots down here. The potential for a pumping station kind of fell off the wayside. So that left us with here, and then as we were looking at these locations, we determined that probably negotiating something with the mall would probably be the most favorable. So where that put us is potentially putting a pumping station down here in the Worcester Court area and one up at the mall area. What happened though is we had initially dealt with the school coming into this system and going to a station over here. We're now looking at the possibility if you would put a pumping station on town-owned property up near the school or the other town-owned property in this general area, could you get gravity flow going the other way? Again, this is just, we're working through the process. So this is not, as Eric said before, we haven't defined all the boundaries, but we need to kind of have an idea of where these things are so we can hone in on the boundaries. By putting a pumping station at the mall, we can address some issues that the mall already has. And then with the gravity low pressure system, anything in green we're outlining would be potentially gravity sewer, and then all these little extensions would be areas that would be low pressure, and then all of this would be low pressure coming up and tying into this. And the flow from this area will go to this pumping station. The flow from what we were calling that sewer area 1 would potentially go up here, or if we couldn't do anything there, we'd have a low pressure system and it would just tie in here and we'd end up coming back to this station. It's all about just different options. And then down in the Worcester Court, you have a combination of things that can tie into the existing collection system and things that have to be picked up and end up down here at the pumping station here. So it's a combination, and I won't point out all each areas, but there's potential to come this way and also to come down and then pump back up. And that flow all ends up at Inner Harbor.
Existing pumping
The
station.
existing pumping station, which I can't remember if I had a picture of it or not.
Yes, you did.
And as Eric had talked about before, as part of the previous facilities plan back in the 80s, they had looked at taking it from, and I apologize, I don't remember the exact boundaries, but I believe it was a chunk of this and a middle section of this. So the flow regime was different, but the idea was those areas were going to eventually end up coming to here and then work their way up to the Jones Pond pumping station. So we then look at, from our pumping station at the mall, and again, the shortest route would be to come Jones Road and over to the Jones Pond pumping station, but you're also dealing with a major road and the issues with that. On the low pressure side,
I just want one conversation around where pump stations may or may not be able to go.
okay,
I don't know how far you've gone into this, but how did you ascertain what sites might be available for pump stations? And where I'm going with this is, there are a couple of empty lots, okay, in that area. But if we're gonna cover it, we need to rule out why we didn't consider any of them. At least there's one I know that's for sale in the peninsula. Okay, the town, it's not, I mean, there's not many, I think there's, I know of at least one.
One
Okay.
empty lot for sale.
I know of one. I'm just wondering, when you say that, you know, these are the only locations, if we ruled out, if we went somehow through the town records and said what lots are occupied or not occupied, and the ones that aren't occupied, what's their ownership, and are they possibly available for sale? Did we do that exercise?
Yes, and we're doing it again. So
Yes.
we're in the middle of the process. So what we've done is we, as part of the first round, as part of the facilities plan, we identified a property down here that we thought we had potential.
Okay.
We actually drove out there this year, and it's all fenced in, and you can tell it's obviously part of somebody else's home. There is another property in that general area that was a house that was for sale, but I believe it's actually, looks like it's 3 lots, but it's
It's a
one-
larger lot,
it's
but
one
it's all
house.
one lot.
It's all one
It is all,
lot.
And the house is for sale.
I know, I'm trying to, I mean, this is hopefully what we. There is an analysis that we need to get to go out there, you know, pumping versus gravity, everything else. If there was a piece of property for sale, maybe even a piece of property with a home on it, but it was in an optimum location, would it be economically viable? Would it save us money on the overall project cost to buy a particular piece of property in a particular area? You're doing this system now, and you're saying, the system is being driven by where you think you can put a pump station. But if you could put a pump station where you would like to put it as an engineer,
Yep.
would it reduce enough of the overall cost that we should consider buying a lot? If it was available. I'm not offering eminent domain here, just if it was available.
Yes, and
Good point.
And as part of the, we've got, as part of the process, we have to go through, and we need to kind of focus on where we think is a reasonable approach, and then we'd have to do some kind of probably less detailed analysis to say, does that meet the criteria of, is that now a viable spot, wherever it is down there, to go and purchase? And do we feel that between purchasing and building a pumping station in this area, would that be more acceptable and cheaper for the town to proceed on that mode, because it would allow you to essentially get back to, you know, more gravity flow
More
coming
of that,
down into that general area.
But if building that gravity system and that pump station is ultimately more money than building the system on the other side, I mean, that's, I think, what you're in the process of looking at a little bit, right?
Yes.
Then we don't need to go searching out if there's a parcel to acquire.
You know, when we met with the Board of Health, I mean, the Board of Health was, he basically indicated, he's like, well, you looked at, you know, the paper roads and road layouts.
Dave Kerrigan?
Yeah, on either side, as well, and we haven't at this point. I'd have to look at, you know, how this is and not
Doesn't
pers-
exist.
and not personally knowing the, you know, how those houses are right now. I mean, you may deal with more issues with people that feel that they own waterfront property that they may or may not actually own because it's a road easement or something like that.
But they don't know.
And again, that comes down to the, you know, there's a town and public piece of it may be the least costly construction-wise, but you're gonna get the biggest fight in the Court of Public Appeals that you'll spend more money doing that. And I'm not saying that is the case, I'm just saying that's another thing that's harder to quantify.
There's a few other points. So one is besides the odor thing that you mentioned, which could be whatever, there's also noise, which we don't know about, and vibration. And in this town, there's a lot of sensitivity to infrasound. It may become a factor in all of this?
Well, the little New Silver Beach pump station is right in the midst of houses. And we negotiated with the neighbors. We decided where the pump station needed to be there, and we negotiated for those private parcels when we built that. It sits right in the middle of that community, and I've heard no complaints about it whatsoever.
Yeah, and you'd have to say the same thing about the Surf Drive site and the one at the head of Falmouth Harbor. The one at the head of Falmouth Harbor has motels right across the street. The one at the Surf Drive has hundreds of visitors coming to the beach. In 30 years, I have not heard any complaints about odor from either one of those sites. If anybody else has, I'd be interested.
Well, and no one complains about the noise from the Shiver's Pond,
Correct.
if there is even any. I'm confused about something else. You would consider spending the money to acquire the property down there, to build a pump station, so that you could build a more gravity system instead of low pressure system. So that's implying that you think actually the gravity system is less expensive.
No, I didn't say that.
You
He
said
asked
that.
me if I, he asked me
I
if
said that we need to make sure that we've.
But I mean, it's close.
We need to make sure that we've done the analysis, so that when we stand up in front of town meeting or wherever else, somebody says, well, if you know, somebody will come up out of the blue and say, well, if you just put a pump station here, it would be all gravity, we wouldn't have all of these things, so it would be cheaper.
I
So
agree
we
with
need
you.
to be prepared.
Yeah,
But we don't know which cheaper is yet.
Well, yeah, I'm not disagreeing with anything, I don't think anyone said, it's just, except at the beginning, we presented that you don't have to build these horrible, big, deep, big pipe gravity sewers. Now there's all this inexpensive little plastic pipe you can put in. But now we're saying, but to avoid having to put in that plastic pipe, we buy a house.
I don't believe I said any of that.
I misunderstood.
What I talked about is the differences in the technologies, and again, you can spend an awful lot of money putting in something that's low pressure, that's a smaller diameter pipe. It's all a function of how deep you go and what else the town's doing with regards to the road and the utilities you're working around and the cost of the pumps. There are economies in low pressure systems and smaller diameter systems have some advantages that can allow you to do that and stay shallow and go quicker and get in and out and do a trench patch and.
But then you have all the pumps and so on.
And you have all the
So
pumps.
that when you look at the total life cycle cost, it's close enough
Well,
that you can't do a back of the envelope calculation. You have to do the detailed design and figure out which one is better.
You have to do a schematic or a preliminary.
We're doing the as part of this, we're doing that preliminary layout to get an idea of where those systems will go. And so what the total length and depths of this gravity would be, what an estimated depth would be for the low pressure system, and how many pumps you'd be dealing with, and building it on that. Okay, but we aren't dealing with, we can only function on whatever utility information that's been made available to us for this. This is a pretty fast-paced project. We're not doing survey, we're not doing the detailed design. So as part of design, there's a whole nother step of going through and then determining where all those utilities are, where all that stormwater system, and oh, by the way, we just redid this, we just put in a whole new leaching system that we had to put in the middle of the road to deal with. I'm just saying, these are examples of things that happen and that you would then have to take into consideration as part of your costing. And then it also gets into what the town is going to elect to do with road resurfacing and things like that. They're all things that add to cost, and some of them will be the same, whether it's a low pressure system or a gravity system, and some may be completely different. And again, so we're going to evaluate them and set the criteria and establish what those apples to apples comparison is, and we'll identify what those caveats are with regards to ownership and O&M and things like that. So there's a lot into it, but right now I'm not going to say which one's cheaper and which one's not. Mr. Rafferty was just indicating that he wanted to make sure that we did a.
When we get into the cost differences, some place we should carry that to buy a piece of property has got a value.
Because there's a, you know,
As part of the costing, so that we can say, and I think there's a lot of secondary issues around politics and everything else about, you know, is it acceptable, or would it delay the project or whatever. But in terms of being prepared on the floor of town meeting, and somebody says, well, why don't you just bring the gravity down there and buy a piece of property? We should be prepared to say, well, if we were to do that, it costs this, and this is what happens, and here's why. It's more than just that. That's all.
There is one other factor, and that's the flood zones. And when you get towards the southern end of Mar Vista, you get into the, yes, you.
But that's.
Well,
in flood
well,
zone,
then you
so-
end up with something that's elevated.
Again, yeah.
Nothing else in the area is elevated, so oh, okay, these are all factors, but.
They're all factors.
I hear you.
I think we can assume, Judy, in the heights, I think the average property value in the heights is around 400,000 to 500,000. And I don't care if it's a shack, it's 400,000, if it's a better shack, it's 500,000. And that might be similar to the lower portion of Mar Vista at least. So my guess is gonna be it's.
So we're 450 is a working number.
We're not talking about cost today.
Well, no, the cost, we're talking about the alternative
I'm
cost.
trying to open that up.
yes.
Next week, we're talking about windows.
I consider we were looking at the 30% design level, the question is, are these questions which go beyond the 30%?
Well, what would happen, what the steps are, you do these layouts first, then you do the cost analysis, and then there's gonna be a decision between the town and the committee on what way they wanna go, and then we'll do a 30% design layout based on that. That's the steps in the process.
How far
So
does
we're
it
not
go?
doing a 30% design on every one of the technologies. We're looking at we're evaluating all the different options, and then we do a 30% design on the one that's selected.
In that 30% design, are you then going to include questions like the one that Steve is raising here?
I think we're past that by that point.
Did we answer by then?
Yeah, at that point, you would have you would be settling in on various station locations. Now, that doesn't, again, a 30% design, what that's gonna give you is essentially plan and profile to give you an idea of how deep the collection system is gonna be, what it might look like, what typical details you'd have depending on whether it's a step or a grinder or a gravity type system, and how it would lay out in these different areas and what pumping station it would go to, and there'd be some decisions on the type of pumping station that would be considered for those areas, and depending on the location and how you want to design it. And then, it never precludes the town from saying that, okay, we've got a 30% design, and then you get into full design and move forward, and there's an issue that came up that, you know, between the time you did the 30% design and when you actually go to final design, and National Grid decided to put a 12-inch gas main right down the middle of where you were putting all your sewer, or whatever it is, those things happen, and then you have to then go and say, okay, well, we've got some pretty good information here to move forward, but we're gonna have to adjust that based on this. Or all of a sudden, there's some great location, and the only reason that, you know, the cost would have been beneficial, but they didn't think that there was the political will to put a pumping station down there, and now there is, something's changed there. You would have that information from this process that you could move forward with. But, again, you know, there's always things that come up, or you know, for whatever reason, the pumping station at that location falls through, and just can't get it negotiated. Because we're not negotiating any of these things at this point. We're just coming up with the preliminary design. And I'll tell you from experience, moving it from what looks like here to, oh yeah, let's put it over there because I like it on that side of the street, could have a huge impact on how deep your sewer is, because all of a sudden the topography is in a higher area, and there's all those things that can come into play. So again, it's a preliminary design. It's to develop the costs so that the town can go to town meeting and appropriate those necessary funds so they can move forward.
So is a modern gravity system now done in plastic welded pipe, or?
No, it's typically all
So
bell and spigot, you know,
It's
it's
plastic.
push on.
Plastic.
So what are the infiltration problems in a modern system? Do you basically, it's not an issue?
Comes into the manholes. That's all.
You're saying it's not the piping, it's the manhole.
Get a heavy rainstorm, someone come in around the manhole rim, but it doesn't exfiltrate or infiltrate, sit in the ground. Normal operation, doesn't leak. You can go to New Silver Beach, you can look at the flow records at the treatment plant against the water records. There's less flow going to the treatment plant than water records because people are using outdoor showers.
I mean, that's not true historically.
Well, ancient times, they built them out of vitrified clay, but they don't do that
That's
anymore.
in what's all now.
Yeah, I'd say virtually any new system's gonna be.
Infiltration is not,
And that's gonna be true even after 20 years.
Well, you know, I'll never guarantee anything because the largest earthquake ever held in the United States that anybody's ever recorded happened in Missouri back in the 1840s and changed the course of the Mississippi. So if we got, God forbid, a level 9 earthquake with a fault zone right across the middle of Mara Vista, we probably would have to dig down to the plastic pipe and reconnect it. So I'm not saying never. People are not dealing never here, and I've learned that, you know, somebody will find an example of a pipe that broke in San Francisco. Just sticking with the realities.
I'm just talking about ordinary wear and tear of equipment and so on.
Well, you hope that the lifetime projections on plastics for years longer than the plastics have been in existence
Yeah.
have been done correctly.
Yes.
Well, okay, so we'll go with this. I'd say compared to metals or clay pipes, which tend to leak phenomenally because they're not very long sections, okay? Plastic pipe is away from the sunlight, underground, so therefore it doesn't have much in the way to cause it to degrade. We have all domestic wastewater here, and except for the foolish compound of concerns that keep coming up, it's your opportunity. You know, there shouldn't be anything that would be causing degradation of the plastic. You know, it's water, it's pH-adjusted water coming off the water treatment plants when we have it finished, right? So you don't have any acidic things, it's not gonna,
Doug Brown has that issue.
Yeah, and I'm sorry if I missed it when I had to step out with a call, but where does the current end of the line exist? Is that true that it's at the Spring Bars Road intersection?
There's one right there, so it extends.
Stop and shop.
Corner.
Okay.
One more block.
the Admiralty is not on, right?
Correct.
Right.
It's not.
But Stop and Shop is, I actually, this map over here, everything in orange, that's on the existing system. And, I mean, there's more to the left, but we colored in what is near the area that we're talking about now. So anything in orange is already on the system.
Stop and Shop paid, and they came down Moran Ave, I think, and they came in that way, so that's why you'd say, well, Stop and Shop's on it, but the Admiralty isn't. It was just, they wanted to do
They came
something.
out through the back.
Right.
But all the wastewater from this area, you know, or sewers would go to the pumping station over here, right?
Maybe.
No.
No.
We're, our original look was a pumping station. We had a pumping station north of the mall. We had it coming down 28 and then coming over, and then coming into Shiver's Pond, which is over here. And there were some issues with the route that we had selected here. And then this station location is looking less feasible, so that put us down here, below the mall, south of the mall. So the idea would be then you could come down Spring Bars and then work your way across Jones Road and end up at Jones Pond. On this map. But some of this flow does end up at Shiver's because it comes in and will come to Inner Harbor and then will come down this main and then would end up at Shiver's Pond. So that's why we sort of broke out this piece from this and this. Because this peninsula, the Mara Vista Peninsula and this area by the school would come over here, and then this area down here would either tie into the existing system, either by gravity or low pressure directly, or end up at a pumping station, which then pumps up into the system, which ends up at Inner Harbor. And then Inner Harbor pumps up into the main on Main Street.
But is it, I'm sorry, is it just too much to all go into the one connection then?
Where?
Well, you're saying one section would go down Bricktown Road, and the other section would connect to the existing pipe?
Yeah, there is a concern, we're going through the capacity, as part of this project, we're also looking at capacity analysis. Now, this was originally designed to deal with a part of Falmouth Heights and a part of Mara Vista, and not the same lake, not the same configuration that we have here.
I see. So you don't expect to find enough capacity for all of it anyway?
There's a gravity line that goes from Falmouth Inner Harbor Pump Station back up towards the Stop and Shop, Jeff, right?
I think what Doug is
That
saying,
line in there, that gravity line
Yeah,
that goes
this
from
one.
there
Yep.
down to there. The question is whether that's got enough capacity.
Oh, yes, there is concern about the size of this coming down and its capacity to pick up all this flow from Mara Vista to dump it
I
into
see.
that.
Okay.
That was the concern there. There's also some concerns with the slope of the pipe here, that was when it was installed. You know, so we're looking at how much we want to actually put in there and what that impact would be on this collection system. This is a pretty big size pipe.
Okay.
But if it comes down here and ends up, one, if it's restricted in flow coming down, and then if it's restricted by the pumping station, you can always
Change
make
the
changes.
pumps.
You can upgrade the pumps and things like that. It deals with the wet well, but this may be more flow than what this had originally been designed for.
So it's a possibility of another phasing of.
The other thing is, you know, in terms of operation and maintenance, if you're pumping from here and you're now pumping twice to get to the treatment plant, here you're pumping once, twice, 3, 4 times. So you've now taken that flow and you've shuttled it all the way around, so you're now pumping that amount of flow 4 times to the treatment plant.
So we'd have to put in 2 new lines, is that it? Going to the 2 different stations from this area?
No,
One.
this one from this station would come up here and tie into the collection system that would end up at this station that's existing, and this line's already there. This is all this is here. So you'd have one new, and then it would likely be a dual main. And then the school here would probably pump down into the collection system that would end up at this station. That would be the likelihood. I mean, there is the possibility that you could use this and pump here, or the town may say, well, you know what, we like the idea of going gravity to here, but we might put that off and see how it ties into something else in the future. We've got a viable location, but we may end up pumping this some other way. Or, you know, again, it gets into how the town elects to want to phase and so forth. That's why we're trying to break things out so that more often than not, whenever we do these things, someone comes in and says, well, what if you added that? And what if you took out this? And what if you moved it over here? So we're trying to build in some of that flexibility. We obviously can't think of everything, because someone will always come up with some other way to send something.
Would a school be considered really a high load or a lower load?
Schools are difficult wastes to manage, because like an elementary school typically is gonna have a higher nitrogen, you know, it's gonna be, it may not have a higher nitrogen load, but it's a higher nitrogen concentration that is more difficult to deal with. So what we found is that, you know, schools that are mandated to put in their own system typically would like to get them to pick up other areas if they had to put in their own treatment plant, so that they can get a more balanced flow, they get that summer flow that they wouldn't have, and they'd also get some residential flow to kind of help dilute their waste a bit.
But for what we're doing here, Jeff, which will be gathering from these properties
Yep.
up to the main treatment plant,
Yep.
the dilution factor should not be an issue.
No.
This would just be, we're trying to size the system only for a school at the location of the school.
Yeah, and this would be this is just a pumping station, because it's not treating
Yeah.
anything. But the waste itself from a school, if it had to be dealt with by itself, and you were trying to manage nitrogen, it's a lot more difficult. So you want to bring in other flows and other, you know, residential flows for both. No, I know, but I'm just saying that would be why you would want to do that, to answer his question about, you know, is it a more difficult thing? It is a more difficult thing to manage, but here with the collection systems, it's irrelevant, because you're just pumping it into your system and then you're dealing with it.
Pumping the flow of the treatment.
I'm just curious about if it had a unique condition.
It's all peat, that's the unique.
Yeah, but it's,
Well, there's no laundry.
that's right. But the school is, the schools are closed during the summer season, so, and I actually think it's a fairly good fit for this seasonal area. Its flow is in the winter, and the summer flows will increase, but the school will be closed.
And once again, we have the example of New Silver Beach to look at, which has got the North Falmouth Elementary School tied on to that
Same
system.
thing.
So they utilize the North Falmouth Elementary School during the winter when the flows are so low out of the neighborhood. It balances out a little bit. There's a little bit of trick in the June time period when it ramps up.
Yeah.
The assumption you're going on when you're planning all of these things is you're planning for the sewering of all of the areas which you've indicated. The areas which are, and what would be the, we are looking at possibilities of reducing the areas that have to be sewered by things that are being done in Little Pond now. Is that going to be built into the, can it be modular, to what extent can this plan be modularized based upon projected possible reductions at this point? I mean, I know we're not going to be talking about those issues at this point, but is this plan modularized?
I'll answer a piece of that, which is, even if you sewer all this, you'll need supplemental reduction to clean up Little Pond entirely. Doing this will bring it down a lot, it won't bring it down all the way. So
That's the assumption at this point.
yeah, based on the MEP studies. This takes far and away the biggest chunk of it all at once, but you would have to be completely clean and back to the level where we all want it to be. These other things will have to contribute.
That's the assumption that's being made at this point.
Systems can be phased. I mean, if there was the ultimate goal, what would typically happen is then you would probably build your collection system, if it was going to be gravity-based, and I'm just using that as an example because I've got the math up here. If you were doing this gravity-based, you could build the gravity pieces and then do some or all the low-pressure pieces at another phase. But if you're going to be, what happens is you're going to be digging up this road and stopping there, it's more expensive for you to come back and dig that little run than it is to do all of that. But you may say, well, you know what, we could stop here and do this piece and get this pumping station all up and set, and then similar here, you could say, oh, well, I've got all these places where I could connect by gravity now, and I don't have to deal with, pumps or anything else, and I can tie it into the existing collection system, and you could build those kinds of pieces and then branch out into other areas in the future. I mean, you have that possibility. With a low pressure system, it's really just, at that point, if you wanted to draw it where you wanted to draw your line. You wanted to draw it there, you want to draw it there. You can, you can slice and piece if you truly wanted to do that.
So in that case, for example, if the side that drains into Bourne's Pond rather than Little Pond, where
Great Pond.
Great Pond, I'm sorry, Great Pond is rather than Little Pond, you could leave those, you could plan to leave those undone or done in some other way.
You could. My caution is that it's great to look at a watershed line,
Yeah.
but that's all it is. It's a line.
Yeah.
And in reality, are you going to stake your life on where exactly that line is?
Yeah.
That it's exactly on this guy's house, and if you pick him up, you're definitely getting it out of here and not out of there, or vice versa. I mean, this is all for planning, so you have to be able to plan that, and you'd spend gazillions of dollars trying to map exactly where every single person went. So that's why some of these lines cease to, when you start talking collection systems for a cluster system or for a treatment plant or for tying into an existing system, the lines cease to follow watershed lines and begin to follow what makes sense with regards to topography and neighborhoods. Because the first thing that's going to happen is you put in a sewer and you stop it right there, and the guy next door goes, yeah, I wanted sewer, why just stop there? Why didn't you go another 10 feet in front of my house so I could connect? I mean, there may be the other person that says, whoa.
I want you to stop.
Yeah, why is But those are the kinds of things, so, and it does, this example of showing you coming down with gravity and then stopping there and saying, well, we'll do that later, that's probably gonna cost you a lot more to do, and be a lot more disruptive, to come back into each one of these neighborhoods a second time, because everyone here is gonna be going, oh man, they got all this construction.
Is it safe to say that all of the alternatives demonstration projects, if they prove to be feasible or partially feasible, will reduce future sewering costs? In that planning for them here, as Jeff just said, is just good planning and is not significantly adding cost to this project.
The other thing about it is just, some of this may be a pipe dream in terms of the money available to do however far we can go. So there's a financial dimension to how far we can go as well, ultimately, when it comes down to that, because the town has a lot of competing demands for resources. So it'll be, I mean, this is obviously water quality in Little Pond, however it's done, it's a high priority, as well as the other ponds, but it's a high priority. So, but still, there's competing things, so you're breaking it up, and things like this are probably very prudent.
Eric, can I rephrase your statement as a question? I think it might be what Jerry was trying to say. If all the alternatives, except for the oysters and the inlet widening worked to the best reasonable extent, you would still need all this sewering?
In this particular water body.
Right.
This project area.
This project area.
Little Pond, that would be true. Might not be true in Bourne's Pond. I mean,
No,
every pond is different.
Right, just here.
I'd say 15 acres of oysters in there might do it.
Well, you're gonna find out.
We're gonna find that out.
I'm saying, rule it out there.
But if acreage of oysters work, we've got 14 ponds.
Yeah, well, keep going.
We'll be happy to
Keep going, I'm just saying.
I want to make sure that everybody who is not on this committee and who is from the neighborhood and who is hearing this for the first time has a chance to tell us what you think or ask anything more you want to ask. We've been immersed in this stuff for a long time, and you haven't, so
Keep using that word, Eric.
I was waiting for someone to object.
I gotta say, my street's 2 streets above the line now.
Is that good or bad?
I think it's bad.
So you want to be in? Yeah. Well, okay, here we go.
I want Perch Pond to be cleaned up, you know?
All right. But any of you, I know you've all been.
I know the T-ticket, the sewage and T-ticket is horrendous. A lot of them have just leaching fields. So the entire Little Pond, that whole area's gotta be sewered, in my opinion.
Yes.
Because you stop it somewhere, all the ones at the bottom, they don't have tanks, they don't have anything.
It's cesspools.
Cesspools. I mean, I know for a fact, you know?
Yeah.
Not mine, mine's new, but still not, you know.
Yeah, C is actually doing some work at the Department of Health, looking at everybody's records for several blocks, just to determine exactly the numbers of what you're talking about, because the suspicion is you're exactly right.
Oh, yeah.
That an awful lot of these people are on old cesspools.
John and I both sit on the Board of Health. And I'm not going to speak for John, but I'll tell you that whenever somebody comes in from Mara Vista, because they're changing property and they have to put a Title V compliance system in, I am always amazed, A, that on these 4,000 to 4,500 square foot lots that have a building sitting on it, that they find a place to actually put anything in. And that we then have the courage to grant them the multiple variances that they require in order for it to, quote unquote.
Well, it's not unusual in that area historically for your septic tank to be on your neighbor's property.
Yeah, there's some very interesting things. You know, and people are putting plastic barriers between their fields and their houses, and we're checking that they're comfortable taking down the 2 trees that they have in order to make room for this, and ripping up their driveway.
So this area is a really important consideration. If you get to Zone 4, for instance, which you've got the little piece that's left there. From the Board of Health's perspective, when we look at those 5,000 square foot lots, even though that area probably doesn't contribute nitrogen to Little Pond, it's an area which is incredibly difficult to put a Tidal V system in. And so that it just makes good sense. When you've got those tiny little lots, you've got, your groundwater is at 1.7 feet. You don't have the distance to groundwater, you've got a small lot. It only makes good sense to add those to the sewer. Even though they wouldn't be considered on strictly a nitrogen basis. It just is good public works.
John's talking about the area at the very tip.
The foot.
At the very foot of Mara Vista, down by the ocean.
Sicily.
Sicily.
And that would probably be low pressure if they decided.
Yeah.
And the vacant lots in that area probably couldn't be built on because of velocity zones, and that's been upheld in Silver Beach where someone wanted to take a vacant lot that was right on the beach, and they fought the Concom, and they lost. And there's, I know of one vacant lot, you could say that's on the beach, on that side. I was surprised they tried to sell it and they never sold it. So, I mean, I know especially when you look at what just happened in New Jersey, to say, when do we stop expanding infrastructure? But when do you stop people in those neighborhoods? We're not going to buy them out. So, you know, you're still going to put roads in, you're still going to try to maintain a level of infrastructure without necessarily encouraging high-density growth. Or more growth than is right there now.
And when we say that section would be low pressure, could you just remind me again what that actually means, low pressure?
That would be either a grinder pump or a step type system.
Okay.
So you have a pump. That's it. Low pressure just means that you have a low pressure force main with a small pump, small diameter sewer, and that's just an easier way for us to convey it. So it's gravity and low pressure, and then vacuum. So there's really just three general technologies, and then there's variations. The step and stag are variations of gravity and low pressure type systems.
One of the other things I think you ought to be thinking about is a lot of these houses, when we try and put in septic systems, the plumbing may go out the back of the house at the moment. And so if you're thinking about a gravity system, you now have to rework the plumbing in the entire house to get it to go out the front to the street. And so that may be a really important cost differential to the low pressure pump, because you just put the little pump in the backyard and it doesn't matter much. So it's a really an important consideration where the utilities go out of the house.
Now, you can see his research, that's one of the factors that she's going to find out for us for this sample area that we're looking at, is where these tanks are right now.
Right.
Front yard or back yard.
If there's a picture.
Big difference.
Yeah, I think almost, the first 40 that I looked at, almost all of them were in the back.
Yes.
Yeah. Well, I would like to thank this committee for all the work you've done. This has been very informative. I live just opposite Tippecanoe School, so I'm just north of the boundary line there. I lived through sewering in two places, gravity, and again experienced this septic system in the rear with the piping through the house in Braintree and Westwood. So I think the work you're doing is very fine. This has been very informative about the new technology, the pumping and all that business, which is.
And your name?
Joan Power.
Joan Power. Okay, thank you, Joan.
Mike, I have a question. Are you ready to do this again, Virginia?
Yes, I am. With Eric's help, he's been a very able leader of the committee, and you can see that there are lots of issues, and it takes a lot of time.
Virginia and I were there 30 years ago.
30 years ago at the
With
Department
phase
of
one.
Public- That's right,
And
the
you're going to
Department
be
of
here
Public
another
Works.
30 years.
I didn't think I'd see phase two until
Well, we have a very capable bunch of people
Yes,
who
you do.
who have been working like dogs for about a year.
Absolutely.
But we've learned to ask the right questions, or at least we think we have. And now we have a capable guy who's gonna figure it out for us in the next month and a half.
That's right.
And come up with real numbers and real recommendations for these different options that we've all talked about today. We want it to be as inexpensive as possible and as painless as possible to the homeowners. You know, you do not want some system that's gonna back up on you or cause fire trucks to show up. You don't want anything that's
Or
gonna
bankrupt you.
or bankruptcy, right? So we're hoping to get a compromise that does all these things as best we can. And we really appreciate you coming today, and we really appreciate your input.
Thank you. Thanks.
One last, if I can. I apologize, I didn't show up on time. What is our schedule and what's the next step? Do you require direct feedback from this committee, or is there a time that you're coming back?
Yeah.
With something direct to this committee?
I'd have to go back and look. We're approaching the point at which we're going to be submitting some technical memorandums and costs to the committee for review. The committee in the town, we're still drafting.
But our committee, when we receive those, is going to need to read them and act upon it at the very next meeting, because if we carry them over from meeting to meeting, it's going to impact your ability to meet your schedule. Is that correct?
Correct. I mean, we'll have to do it in advance of your meeting. You'll have to have the opportunity to review it. And then we'll probably be dealing with comments and then making
We should
revisions.
try to set this up that we get, whatever we're going to get from him, that we should get it on or before, like, let's say, close of business on a Monday. So it can be published, everybody on the committee, so they have Tuesday and Wednesday and Thursday to read it, so we can act upon it on a Thursday night and keep moving. Does that make sense?
Have it on the agenda for Thursday, yes.
So, one element in this though, if all this is contingent on our getting a discharge permit for this added volume, right? This whole design, this whole
You gotta be
concept.
ruled out of order, right?
We have an adequate permit.
We have a
On the
discharge document.
29th, we will have a discussion about discharge permits, not today.
When is the next schedule?